YouTube, it's me, mdickens98, and I'm here to do another video this evening. And this evening I'm going to be looking at DeLidding. Yes, this is a very interesting topic I've come across recently. In the process of looking at building a new PC, I decided to basically investigate what would be the best CPU to buy for playing games. That's all I use my PC for. Looked like the Core i7 7700K was going to be the best option, but people were complaining a lot about high temperatures, particularly when overclocking a chip. Now, if you buy a K series CPU, they're not cheap. If you're buying it because you want to overclock it. That's why you buy the K series one, the unlocked multiplier. No point having an unlocked multiplier and paying extra for it if you're not going to overclock, right? So, people were talking about DeLidding. Did a little bit of reading about it online. It looked like something that was a little bit dodgy. I had seen it before. People were using Stanley blades and scalpels and all sorts to try and cut the lids off their CPU and doing all kinds of nasty damage. But basically, what DeLidding is taking your CPU. Let me give you a idea here. This is not a good sample, but here we've got an AMD Athlon 64, horrible old CPU. On the top of it, this big metal plate here, this is a heat spreader. And what you do is you basically take the heat spreader off. Underneath there, you've got the CPU die. You clean up all of the material that's been used for thermal transfer, and then you replace it with something better. And then you stick the heat spreader back on. Some people have been running them without heat spreaders. The problem with the i7 7700K and I guess other Kaby Lake chips is that the sockets on the boards don't allow you to mount the cooler properly. If you haven't got the heat spreader on, it won't make good contact with the die on the CPU, so it will cool really badly. So after reading about it a little bit, getting all excited about a new project to try, I thought, well, I definitely want to try this before I go and butcher a £300 CPU on something a bit cheaper. And then I saw videos about a German chap called Der Bauer, and he basically has built a tool for DeLidding safely. So I had a little look and found that overclockers in the UK sell these, and they didn't have any in stock, but when I checked back a couple of hours later, they had 3 in stock. So I got all excited and went and ordered one, and here it is. It's the Der Bauer, I believe that's how you pronounce it. It could be wrong. DeLidding tool. It's a Delid Die Mate 2, and it's in this little box here. We've got a couple of parts here. We've got a little plate used for remounting the heat spreader, and then we've got the tool inside this nice foam box here. So, why am I staring at a Fujitsu PC, you may be asking? You may remember this PC from my last video. It's not actually the same one. I got 2 in a bundle, but sold the first one, and now I'm having a bit of a practice with this one. So in this machine, we've got an i3 4160. But it's a CPU that I know is going to probably be a good candidate for me to practice DeLidding on. Why DeLid? So one of the problems, actually let's go back a little bit. If you go back, this thing, when I was younger, when I was at college, probably the early 2000s, I remember building PCs around AMD chips, and they didn't have heat spreaders on them. You would have the CPU die exposed straight on the chip, and that was fine. But apparently people were a little bit ham-fisted and used to damage them, and they get a high rate of RMAs. So what they did was they thought, let's protect the die, put a heat spreader over the top of it. It will help mounting the CPU, it will make the chip a bit safer. There's probably other reasons as well, but you can read more about it online. I'm not going to go into all the details. But that was all good and well. What they used to do is they used to actually use a tiny blob of solder to solder the die onto the heat spreader, and this meant that the heat transfer was really efficient. But a few years ago, not long after I built my last PC, so my last PC was a i5 2500K, that's a Sandy Bridge generation PC. Not long after building that, they decided that they didn't want to solder anymore, and they would just put some thermal compound on the die, glue the heat spreader back on, and it will be good. It works fine, but people quite quickly realised that it wasn't very efficient and that the chips were getting a lot hotter. I remember not long after building my PC, the Ivy Bridge range of CPUs came out, and people were immediately complaining about the i5 and i7K series chips running much hotter than the Sandy Bridge ones. So this practice has maintained, and it seems from what I've been reading like it's as bad if not worse than it ever has been. So basically what we do is we take the heat spreader off, clean off all the thermal compound, and put some better stuff on, and then refit the heat spreader again. Now I've done a bit of reading online, and I've gone for this. This is Cool Laboratories Liquid Ultra. It's liquid metal, and apparently carefully applying this onto the die will give some of the best heat transfer that you can get. So this PC's running. I'll just show you the screen here so you can see what's going on. I'm running a little stress test, Intel Burnin Test, just to see what temperatures I'm getting before DeLidding. I mean, this isn't going to be of any benefit. I'm not expecting to get anything out of DeLidding this. I'm doing it to practice, but I would like to see the temperatures drop a little bit. You know, it's not an unlocked CPU. I'm not going to be able to overclock it. I'm not going to be able to run it any faster. But I wanted to see how it went. I wanted to see how the process went without risking a £300 CPU. So at the moment, I've just cleaned off the original TIM or thermal interface material that was on the chip. Reapplied some fresh Arctic MX2 compound just to make it a fair test, and put the cooler back on. Running Intel Burnin Test, I'm getting peaks of around 80 degrees C on one core and 76 on the second core, which is actually about the same as what I was getting with the original TIM, but the idles have dropped about 3 or 4 degrees. That's fine. So there we are. We're at 80. Oh, I say 82 then, but I didn't run the test list long last time. That's hit 82 degrees on the first core, 76 on the second core. So that's what we're looking to beat. Okay, so join me in a minute when I get the CPU out of the case. So here we are inside my Fujitsu PC. What I've done is I've taken the side off, obviously unplugged it, and I've loosened the 4 screws holding the CPU cooler on. So that should now lift off. A bit of persuasion. This last screw is just holding. I'm going to unplug the power cable for the fan, and there's the chip there. So as you can see, nice even spread of CPU paste. I'm just going to wipe that off with a tissue. This Arctic MX2 is quite thick, so it tends to stick quite well. The original stuff was a bit thinner, so it came off more easily, but this has only just been applied, so it's not too hard to get off. So there we go. That's most of that off. I'm just going to use a little bit of isopropyl alcohol. Very handy stuff to use for cleaning this sort of thing. Spray a bit onto a tissue. Give it a wipe over. Just make sure we're nice and clean. And there we have one CPU ready to come out as our test subject. You'll see it's an i3 4160. Hopefully you can see that in the video. So just release this detention bracket, flip that up, and then we can pop the CPU out. There we go. Right, so I've got the CPU on my bench now, and I've just had a look online at the URL supplied. Takes you to this nice page with instructions, which goes through everything I need to do to complete the DLID. So I'm just going to run through this, and I'm going to do it on video so you can see what happens. So step one is to unpack my Delid Die Mate and remove the re-gluing tool from the Delid Die Mate 2. So we'll take that out of the box. We'll take this key out of the box as well, because that's what we need. And then we've got the Die Mate 2. Now, this part here, this is what they're calling the re-gluing tool. This is used to clamp it when you put your heat spreader back on. So just undo that, take that off. Don't need that. Okay, and then once we've done that, we need to disassemble it by taking out the screw and slider. So we've got a hex screw here, right side is for the Allen key. And just undo that all the way, completely disassemble it. Take out the slider. Okay, insert the CPU. Make sure that the triangles of the DDM2, the Delid Die Mate 2, and the CPU align. So here's my CPU. Triangle is in this corner. Triangle on a Delid Die Mate 2 is in that corner. So I'll pop it in. Okay, there's a nice groove recess in the bottom of the Die Mate 2. Just make sure it sits in there, which it has. And now we need to add the slider, which sits in grooves on the side, and the screw. Okay. Then you use the hex key to tighten the screw. Keep turning until you can feel that the heat spreader is moving. In some cases you need to apply a lot of force to move the IHS. That's the integrated heat spreader. Make sure that you inspect the current progress and don't over tighten. Now, I've never done this before, but I've seen people doing it online. When I've seen people do it, it tends to go a couple of screws. Oh, well, it's up tight anyway, finger tight. It'll be really tight and all of a sudden it will give. So where's it where it goes? Oh yeah, so that's very tight now actually. So oh yeah, feeling some give. There you go. Right. Sorry about that, but you can see that heat spreader's moved quite a lot there. So remove the IHS and CPU. Surely it should tell me to undo that screw. It doesn't. Okay. Well, common sense dictates that I've got to undo that screw now. What do you want to do? Take the slider out, and that heat spreader should now come off. And it's loose, but it's not. There we go. There we go. So there we go. That's the heat spreader removed. That wasn't too bad, was it? It's a lot better than going at it with a Stanley knife. And I can't see that it's done any damage. It's just literally released the glue. Okay. So, next stage on that is to clean up the heat spreader and the chip, ready for relidding. So, on the bottom of the heat spreader, you've obviously got the original thermal paste, which doesn't look particularly different to what you'd see on your normal cooler. Right, although that is, it's a bit dry. You can see it's sort of flaking off. I'll get some isopropyl alcohol on that. Doesn't take a lot. I mean, all we want to do is remove the compound. Okay. That's left a stain, but it's pretty clean. And then we need to do the same on the chip. Yeah, that paste is quite crusty on the edge there. Yeah, it's all just flaked off in one piece. Not great, eh? Just put a little spray of the IPA on there. Give it a gentle wipe with a tissue. And what you should get is like a mirror finish on the dye inside. Which we've pretty much got now. Apart from all the tiny little fragments of dust coming off this tissue. But you can see that's like a very shiny mirror finish there. Blind you with a flash. Right, so the next stage is to clean off all this glue. I've seen people literally just pop the heat spreader back on and not glue it. I would be happy to do that for this test, but I want to practice gluing it back on, because when I do, if I go ahead with the purchase of the 7700K, I'm going to want to actually glue the heat spreader back on. What I've bought for that, I'll just show you. It's what people were recommending online. It's this. I wouldn't worry too much about the brand, but basically it's RTV silicone. RTV stands for room temperature vulcanizing, which basically means it cures at room temperature. It's a gasket maker used in cars. Basically just put a very small amount around the edge of the heat spreader, push it on and leave it, and it will cure at room temperature, set, and then you'll have it refixed. The nice thing about using a gasket sealer is that it will create a seal very similar to what was originally on there, which means that if I ever want to remove the heat spreader again, I can. And you'll also notice that there's a gap. The original seal goes around the outside. There's a gap left here. The reason for that is because with the temperature changes, you could end up with the air expanding or contracting inside the heat spreader and causing pressure. You need to leave a gap for that pressure to release. So that's why they do it. So I just need to copy that when I refit it. So I need to remove all of that black gunk, and I need to remove the black gunk from here as well. I've seen people use a variety of different tools to remove the black gunk, but because I don't want to damage the chip, obviously I've bought the DeLid tool to delid without damage. I need to use something plastic. I've got this plastic Pro Tool here, which is quite chunky, so what I'm probably going to do is use this one. This is like one of the little plastic spudges that you use for repairing mobile phones and such. It's like pence. And what we should be able to do is just literally scrape away at this. Remove it. It does feel like rubber. It's like a rubberized glue. So what I'm hoping is that the majority of it will actually sort of peel off together. Yeah, I mean it is sort of coming off in chunks. Yeah, you can sort of see it's coming off there. So I'm just going to carry on with this for a few minutes. I mean, you can see that that's coming off all right. It's just a case of taking your time. It still looks quite like there's a lot on there, but it does actually come off quite nicely with this tool. You can sort of see as I'm scraping. I think it's probably going to leave a black stain on the chip, but as long as I've got most of it off and it gives me a flat surface, I should be able to remount the heat spreader with fresh RTV silicone. Okay, So I'm just going to press on with this and I'll be back in a sec. Okay, so that's actually worked better than I thought it would do. Literally just 5 minutes of rubbing with that plastic pry tool and it's all off. You can see there's some marks left on the silicone from where it's been. I could use some isopropyl alcohol and work for ages rubbing it and trying to clean it to get all of those off, but from what I understand of the purpose of the seal, that's really wasted effort. All you want it to do is be clean so that you can get a good seal when you reattach the heat spreader. You want the silicone to stick basically. So that's fine, and you don't want to leave the old silicone on there because otherwise you'll have too much of a gap between the heat spreader and the die. You don't want to make it too thick. So I'm quite happy with that. So I just need to get the rest of the silicone, or whatever the original gasket seal is, off of the heat spreader. So you can see again here, this is where they've left the gap. And again, it should just be a case of sort of rubbing with the pry tool around the edge to try and get the remnants off. I want to have it clean. You can see that's coming off relatively nicely. I want to get the majority of it off. It's only really around this edge here, the outer lip, that I need to get it off. Most of it's already off there anyway, but it's left quite a lot of residue on the inner lip, so I will try and get that off just for the sake of trying to do a good job. Doesn't seem to be taking too long. Right, so I've finished cleaning the heat spreader. You can see that's looking pretty clean now. And what I've decided to do, because this is basically being done as an experiment, you know, I'm practicing here and I want to see how much of a difference it makes before I go ahead and make sure I can do it and I'm familiar with the process before I go and potentially ruin an expensive CPU. Yeah, so there's the heat spreader and there's the chip. What I'm going to do is I'm actually going to try just putting some normal thermal compound on the die first. And then I'm going to put the heat spreader on without gluing it as well, and just see how much of a difference it makes first. And then I'm going to try the liquid metal and the new gasket approach. So to reattach the heat spreader, if I put the chip in back in here this way around, make sure it's sat in the groove, which it is. Again, making sure the triangles line up. The heat spreader then goes back on this way up. But what I'm going to do first is going to grab my thermal paste. I'm just going to put a tiny little grain of rice in the middle. So, don't want to use a lot of this because it will get spread out when I apply the heat spreader. Then we have the nice positioning tool, which is just here. We pop the heat spreader into the positioning tool this way up. It should just fit nicely. And then, according to the instructions, literally slide that into there. It's all a bit awkward actually, isn't it? Yeah. There we go. Basically have to get everything sat on top of each other and it will hold it in position. And then we can take the clamp, loosen it right up, go over the top, go this way, right over the top of the chip, and then tighten it down. Now, if I was doing this with the RTV silicone, what this would be doing is it would be affixing the thing in position and making sure that the glue or the silicone sealant pressed down nicely to make a good seal. And then I would leave it for 24 hours. But as I'm not gluing it for this test, all I'm doing is just clamping that on. It's probably not really going to do anything more than very lightly hold it, if it even does that. So I need to be careful when I take it out that the heat spreader doesn't fall off again. So what I'm going to do is I'm going to grab the case, ready to put the chip back in. Once I've got the chip in the board, the retaining bracket on the motherboard will hold it in place. So I'm just going to pop that to one side, grab the case, and hopefully I'll just zoom out a little bit so you can see what I'm doing. Just open this retention bracket ready for it to go on. Now just make sure I can make sure I get the chip in the right way around. So I'm just going to undo the screw on here now and be careful not to let the whole thing slide out. Literally all they've done is just applied enough pressure to hopefully spread the CPU paste that I've put on there. I'll pull that one off, and then we'll very gently release the CPU. Hopefully I can flip this back over without it all dropping off. Yeah, I can see the heat spreader is already moving, so we'll pop that back in its slot and just slide the heat spreader back up slightly to where it needs to be. Now I would not recommend doing this if you're using liquid metal, because liquid metal is conductive, so you need to make sure that it's not spreading around and going onto the PCB anywhere. So I'll drop that bracket back down, clamp it into place. That's it. Moving too much, let me just slide that off a little bit. Just going to hold the heat spreader while I tighten this bracket, because what we don't want it doing is shorting anything out on the chip. There we go, okay. That's in place now. It's not perfect, but it's holding it, you can see. And you can also see there's a set of contact points across the bottom of the chip, just here. You want to make sure that you're clear of those. So the chip's back in the board now. Just apply another bit of thermal paste across the middle. Everybody's got their own methods for doing this. I've always found the best method is just to put a small strip of it like that. That's possibly even too much there, but a small amount like that, and then just pop the cooler on top, and when you tighten it up it will spread it for you. I've seen plenty of people use credit cards, spudges, their finger, all sorts to try and spread it. I've seen people put in cross patterns on, doing all sorts. Less is always more with CPU paste. All you're doing is trying to fill the tiny imperfections in the surfaces to make sure you get the best contact. In an ideal world, everything would be perfectly flat and then you wouldn't need any thermal compound. Just the two surfaces mating against each other perfectly flat would transfer all the heat, but they're not, you know. I mean, you look at the bottom of this CPU coil, I've just wiped all the compound off, you can see it's not a mirror finish. Same with the heat spreader. So you do need something just to fill in tiny imperfections and make the heat transfer good. So we'll pop the cooler back on. I'm just going to do that up. You don't need to watch me do this. So we're just literally doing the screws up in a cross pattern to try and get even pressure. And I can assure you it does spread the CPU paste. As you saw it at the beginning when I took the cooler off, that was after I just applied some fresh thermal paste in exactly the same method as I've just used now. And you could see it had quite evenly spread across the chip, so you know that's perfectly adequate. Right, that's now on, so I'm going to plug the fan back in and then we'll boot it up and have a look at the temperatures. So the case is all back together, just going to power it on, We'll boot it up and see what's happening. I don't really know what to expect here. You know, to be quite honest, it wouldn't surprise me if the temperatures had actually gone up. But it'd be interesting to see. I know the Arctic MX2. This is, by the way, this is the thermal compound I'm using. Arctic MX2. I know it's quite well regarded as being a reasonably good compound. I've got some Arctic MX4 I bought here as well, just in case I run out of that. That's also good stuff. Apparently that's easier to spread, but you know, there's nothing here on there. So just run CPU ID so you can see what's going on the screen. Just get you positioned nicely. So as you can see, it's the i3 4160, so you can see it's the right chip. And then what we'll do is we will run our real temp. Let me just grab the temperatures from before so we can see where we're at. So with the standard TIM, we were idling at 28 degrees. When I reapplied it with the MX2, we were idling at 24. So this is just after DeLidding and replacing the compound between the heat spreader and the die for the MX2. Just trying to wait for an actual idle load. There's background processes that are working the CPU, but I did see 23 degrees on there, which is 23 on core 2, which is 1 degree lower than what we were at before. I wonder maybe if I unplug the. I'm going to unplug the internet cable, make sure it's not trying to download updates or anything from that. Internet cable, Ethernet cable, whatever. Yeah. That seems to have done quite a good job of dropping the load. Okay, interesting. I don't know how well you can see that, but we got 22 on core 2, 21 on core 2. Yeah, so that's helped. That's a 3 degree drop at idle. Give or take. I mean, it's hovering, it's not a massive difference, but it's definitely cooler. We're getting 23 on core 1 is the lowest I've seen, I think. Yeah, we'll put that in as 23 on core 1 and 21 on core 2. So that's 1 degree on core 1 and 3 degrees on core 2. So that is a lower temperature. You know, I can't argue with that. Now I'll run Intel Burn Temp for 5 minutes. Sorry, Intel Burn Test for 5 minutes and see what it does to the temperatures. Properly stress the CPU. Now, after about 5 minutes, we were hitting 80 degrees on core 1 and 77 degrees on core 2. That's with the standard TIM. And then with the MX2, we were getting 78 on core 1 and 75 on core 2. So we just file it off now. And I'll come back in 5 minutes and see how we're getting on. Okay, well, I'm mightily surprised, impressed already. So the test is still running. We've just gone over the 5 minute mark now. But core 1 is at 66 degrees. Okay, it just drops at the end of the test down to 57. We'll let it heat up again. But yeah, we're at 66 degrees on core 1, 64 on core 2, which is a good 10 degrees lower on core 2. 68 we got there, so that's about 10 degrees lower. And that's without any overclock. That's running completely stock. That's with the standard heatsink fan that came in the PC. Standard voltages, everything's at stock. And we've dropped 10 degrees, which is a pretty big result. And it's more, if you actually look at the original temperatures with the standard TIM that was on the chip when it was new. So we're using MX2 between the die and the heat spreader, and again between the heat spreader and the CPU cooler. So if you take the temperatures when I started, before I'd taken the cooler off and replaced the TIM, we're actually 12 degrees lower on core 1 and 11 or 12 degrees cooler on core 2. But with better TIM, we're 10 degrees cooler. So that's really good actually. I'm impressed with that. So I'm going to mark that down as 68 and 70 and 60. So 68 and 66. We're good for that. I've actually, the test is running longer than 5 minutes now. It's just completed its full test. See how quickly it drops down to idle as well. We were at 28 degrees idle when I started, and with it delidded we got down to 23, so yeah, looks like it's going to take a little bit longer to drop the temperatures after that burn test, but yeah, this is impressive stuff. You know, that didn't take me more than about a quarter of an hour, so quite an impressive result for 15 minutes work. But I'll be interested to see if the temperatures are even better using the liquid Cool Labs Liquid Ultra and resticking the heat spreader on. I'd like to see it better. Apparently reattaching the heat spreader does make a difference, so